Okay. on on to market power. Section 2. 2.1. So the point with market power is that a firm knows that if it increases its production, the price is going to go down. Okay. Perfect market, the firm is what we call a price taker. And it's Vattenfall again. And we've got the same cost function and we've got the same demand function, but now we're assuming that Vattenfall actually realizes the power that it has. Okay. But apart from that, the setup is identical. So part A, identical to 1.4, that is. Part A, what are the levels of emissions and electricity production in the social optimum? And that's basically what we already worked out in 1.4, right? So we end up with Q is A minus delta over B, and E is C minus delta plus A minus delta over B. Okay, which is what we worked out in the previous question. And you could either work this out by setting up the social planner's problem, which is the maximization of total benefits, or you can actually work it out by setting up the firm's problem, assuming that they pay the optimal tax, which is equal to delta. And the theory that we haven't gone through tells us that that will always give you the optimum. Part B. In Part B, we just assume some level of the tax, TOR, and remember now it's market power, and we're looking at the firm. So what does the firm do? It maximizes revenue minus costs. Okay. And what's revenue? Revenue is P times Q, but now we know that the firm is aware that P is a function of Q. P is A minus BQ. So P times Q is A minus BQ times Q. And costs are C plus Q minus E squared over 2. Plus TOR times E, that's total costs. So it's minus this, minus this. So the firm sets out to maximize pi, which is revenue minus costs, and the firm has two choice variables, Q and E. And this is surely pretty straightforward. So let's see what comes out of this. Let's take the first order condition in Q, and we get A minus B, BQ squared, 2BQ. So we get A minus 2BQ here. Here we get minus 2 times this over 2 plus sign here. So it's minus C plus Q minus E equals 0. So we can put an equal sign here and get rid of that. And the first order condition in E gives us minus 2 times this over 2, go inside and differentiate, and we get the minus sign, so that turns everything into plus c plus q minus e minus tau equals 0, so we have that. So this is the firm's choices given the tax. And how do we carry this on? Well, c plus q minus e is tau, there's c plus q minus e, so we can stick the tau in here, and then we can solve for q, can't we? Q is, this is just tau a minus tau over 2b. That's q. And what's E going to be? Let me look at my crib sheet. So E, actually I've just done it, E is C plus Q minus tau. So we get C minus tau plus Q plus A minus tau over 2b. So far, so good. Set tau equals 0 to give laissez-faire and compare emissions and production to the social optimum. So when tau equals 0, Q is A over 2b. And E is C plus A over 2b. If we were also to put delta equal to 0, then we could say unambiguously that this is A over B, this is A over 2B, so with market power there's too little production, and we would also have C plus A over B, and here we have C plus A over 2B. There's too little emissions when there's no damages. When there's damages, we want somewhat less production because of the damages, and depending on tau, it could be that even when tau is 0, the market power is giving us less production. So it could just happen to be that this turns out right. But here we have C plus A over 2B. Here we have C plus A over B minus delta over B. It's really unclear what we can say. Let me have a look at my crib sheet, see what I said there. When tau equals 0, we cannot say whether production or emissions are above or below their socially optimal levels. Yeah, okay, so when I was sitting in my own time looking at this, I couldn't come up with anything cleverer to say either. Okay, but it's unlikely to be spot on, and especially we're unlikely to bring emissions down. Even if market power happens to bring the quantity down, it's very unlikely to bring emissions down to the right level, I would say. And it's certainly not going to bring them both down to the right level. Okay. Find the level of the emissions tax which induces the same level of emissions as in the social optimum. What can you then say about production? Okay, so here we're going a bit deeper, aren't we? So we want to achieve optimum emissions, that, through the tax. So we want this to be equal to this. C minus delta plus A minus delta C, sorry, can't cancel these because then that E is not going to be right. So let's just do a therefore sign. And cancel the C's and say that minus tau plus A minus tau over 2B must be equal to minus delta plus A minus delta over B. Now then, let's check the question again. Find the level of the tax, blah blah blah. So we want to isolate the tax. So let's collect terms in the tax and say tau times minus 1, that's that term, times minus 1 over 2b. So equals, so let's get rid of these minuses, make that a plus and put a minus there. Minus tau times 1 plus 1 over 2b equals minus delta times 1 plus 1 over b plus a over b minus a over 2b. And now let's change the sign of everything and say tau equals delta minus plus. Now we're getting somewhere. Let's multiply through by b, and I'm gonna, you should write separate lines for this, yeah. But I'm multiplying through by b, we get b plus a half, b plus 1 minus a plus a over 2. So that's minus a over 2, isn't it? Simplifying that one, b plus 1 there. So tau is delta b plus 1 over b plus a half minus a over 2 over b plus a half. Okay, I'm just going to pause there and check this. Okie doke. So I just checked that off against my crib sheet, and in the crib sheet I've simplified this to delta, which is kind of what you'd expect it to be. So we want to extract the delta, and then what are we left with? And it turns out we're left with, let me check this crib sheet again, I don't want to get this wrong. It's minus a minus delta over 1 plus 2b. Okay, it's actually not that tricky to get from here to here. I'm not going to go through it, I'm sure you can all do that with enough care. So this is clearly less than delta, isn't it? So you tax at a lower rate to get optimal emissions. Okay, so that's the tax rate, and we can stick that into the solution for the quantity. What do we get then? We get a minus delta over 2b minus this lot over 2b. Turns out that simplifies out, and we get q is a minus delta over 1 plus 2b. We stick this in here and simplify it. And yeah, the optimal Q, tau is delta. Oh. What's the optimal Q? A minus delta over B. Yeah. So clearly here Q is a lot lower, isn't it? When we get optimal emissions, we're not going to get optimal quantity, which is kind of what I speculated about earlier. We can't get them both right through a tax. What if we add a production subsidy? Well, we'll see that in the next video.